Alright class, this video is going to walk you through the procedure for our homemade crush test that we did for the YBCO superconductor lab. Alright, so let's real quickly just kind of go through the things that we're going to use and need in this crush test video. The first thing you're going to have is you're going to have to dry press a YBCO pellet, so what we call green. It hasn't been fired yet. So you're going to need that. And then we're going to need our tinsel tester, and we're going to have it set up in a specific way. So we have our 5 kilogram load cell. We have a tinsel grip on the top, as you can see here. Tinsel grip. And it's actually gripping a Rockwell hardness tester, an indenter. And so we need that. And then on the bottom, there's a compression platen. And then we have the actual tester itself. So again, this is the Instron 3382. So these are all the components that we're going to use to do, again, a homemade crush test. There's no ASTM for this. It's kind of custom, homemade for our test. There are actual tests that will do this, but this is just something that we came up with to test the strength of our green pellets to see the effect of the binder and what that had in it. So I'll pause here, and then we will kind of go through the procedure of how to get this set up, and then the program, and then what to look for after the test. Alright, so let me walk you through in a little bit more detail our setup here. So again, we're at the Instron 3382, and we've set up this homemade test. The first thing I'll mention, again, is that this is not a standard test, and we're using things in slightly different ways than what they're designed. So I'm only using this because the forces required to break our pellets is very small. If I expected them to have any higher forces, I would not be using this setup. Because we have the small load cell, which is a 5 kilonewton limit, and then attached to it we have a tinsel grip that you've seen before in other Instron videos. And then you can see here that I've attached into the grips, I've gripped a Rockwell indenter. So this specific Rockwell indenter is the 1/8 inch indenter. So 1/8 stainless steel ball bearing Rockwell hardness indenter. So that's what I'm using for these testers. So what you might be able to see here, that is the 1/8 inch stainless steel ball bearing Rockwell hardness indenter. All right, so that is in place, and it's basically going to come down in compression against our pellet. So we have a green pellet here, and we're going to put it directly underneath the indenter. And that indenter is, or sorry, that pellet is on what we call a compression platen. So basically just a very thick metal piece. And so that's going to hold our pellet, and the indenter is going to come down and try to break apart the pellet. And that's what we're going to look at. So it's going to crush it with the indenter, and we're going to measure the force it takes to do so. So for setup, you want to, if it isn't already, you want to use the jog over here to get the indenter as close as possible to the pellet without making contact. And so you can still slide it in here. You want to go through, so essentially now then you would put the pellet underneath the indenter, and then we would close the door. Sorry about that. So that the safety shield is in place. And then we're going to switch over and set up the program on the computer. Alright, so we're over here at the computer, and again, this is the interface for our 3382. And there's also a keyboard and mouse over here to the right. And so we're going to click on Blue Hill Universal. So this is going to open the Instron software, which is named Blue Hill, as you probably know by now. And the program we're going to use when we log in is going to be the same program as the 4-point bin test that we used for glass. So I don't need any specialized software for this, any specific routine for this, because really the only thing I'm after is what's the max force that this pellet can take before it breaks. And so I'm not really looking at the curve or anything like that. I'm mostly just looking at the maximum force that it can withstand in this very relative test for these pellets. So all the pellets are roughly the same, and then we're going to look at how much force they can take. So it's taking a little bit of time to start out here, but once it gets going, we'll show you what that looks like. All right, after a short delay, we were able to get the program running, and so we're going to go straight to test once we open the software. And like I said, we're just going to actually use the same software, the same test or method that we use for 4-point bend. So that's 4-point bend glass. Because basically all we need to do is have the indenter come down and make contact with the surface. So it's just a simple kind of compression. So we're going to ignore a lot of the inputs that we need, except for we're going to name it here. We're going to give it a file name, and then we're going to choose a location. And there's a superconductor folder up here. So we're putting it into that. So once we have that all selected, we just go, let me pick a different name here. I'll just put test, but whatever name the sample is. And then we're going to go to before test. It's going to ask for a diameter. You can basically ignore all this because it's not going to do any calculations for you. So really all that you need to do, and I'm not actually going to test the sample, but you want to hit start, and it's going to get to the same screen that you've seen before where it has a graph of stress strain, and it shows you what it looks like for this. And it'll also calculate the max force. And it should stop the test once the sample is broken, but if not, you're going to hit the stop button down here. So I'm not actually going to test this, but I just want to sort of show you what the sample looks like afterwards. So basically, from the software, you're going to use the 4-point bend glass method, and you just want to get the maximum force that this green pellet can withstand. And then we take pictures of each of the samples as we run these, and give you the data files for the max force. We also have a summary data sheet that shows you all the forces for all of the samples. All right, so let me get set up again, and I'll show you what the pellet looks like after this crush test. All right, so after we take this crushed green pellet out from the Instron, it looks something like this. This is one of the Wednesday B samples that we tested. So you'll have that data in the data files. But you'll see that it kind of cracks into several pieces here, and the middle should be the initiation point where there's a cylindrical indentation from the ball bearing that's crushing the sample. So we got pictures of all of these after the test, so you can kind of take a look at what that looks like after the crushing is exhibited. And the whole idea of this test is to have kind of a homemade crush test that will mimic what it's like to handle these pellets, because we want to make the pellets easy to handle by adding binder. And so we can get the force measurements from this crush test and compare pellets of different groups, whether we added binder or how much binder we added, and compare how much force it takes to break it, as again a way of comparing it to how much force is it going to take when we handle it, and can I accidentally mishandle it a little bit and it still be okay, or is it going to break? That's what this test is trying to get at. And so you'll find the data in our share folder, pictures, data files, and a summary sheet with all of the data inputted for your consideration.